What is going on, everyone? My name is Adam Allard at pragmaticways.com, and in this video, we are going to be going over the two-sum code from LeetCode.com. This is a pretty fun one. It's an easier problem, absolutely, but it's kind of fun. So let's go ahead and get into it here. So we are going to be given an array of integers called nums, and another integer going to be called target. And the idea here is that there's going to be two numbers inside this array that are going to sum up to equal target, okay? So there's going to be two numbers inside this array here. When we add those two numbers up, it's going to equal the target. And then once we find those two numbers, we want to return an array of just two numbers here, and those two numbers are going to be the actual indices of the numbers that we found, okay? So for this problem here, we are going to assume that there is exactly one and only one solution. So we're not going to have to deal with the edge case where there's no solution, or maybe there's multiple solutions. All right, there's only going to be one solution per given input. All right, yeah, that's pretty much it. So we have an example here of the input array is 2, 7, 11, and 15, and then the target number is 9. And we can see just that 2 plus 7, well, that's going to equal 9 right away. So we're just going to return the array then of 0 and 1 because this element is at index 0 and this element is at index 1. All right, so we can kind of see conceptually what this looks like, right? But how do we actually solve this? How do we create an algorithm to solve this for any given input? Well, clearly the naive solution, hopefully the easy to figure out solution, would be to kind of use like a double for loop, right? We would essentially start at this first index here, and we'd check it against every other index, right? And we'd try and figure out, this is supposed to be 9, we would try and figure out if any of them equals our target, right? So in this case, it just turns out that, well, right away, if we were to do that, we'd find it instantly, right? So I'm going to go ahead and change this over to 18 so we can see a little bit more examples here. All right, so our outer loop would start here, and then we have our inner loop starting at the next one. So we basically check this against this. We say 2 plus 7, does that equal 18? No, it doesn't. All right, so move to the next one. 2 plus 11, does that equal 18? No, it doesn't. Move to the next one. 2 plus 15, no, it doesn't. So then our outer loop is going to increment by 1, and then our inner loop restarts. 7 plus 11, does that equal 18? Oh, yes, it does. So I'm going to return this index, which is index 1, and this index, which is index 2. So this, like I said, is going to be an O of n squared solution. All right, big O of n squared, sorry. It's going to be a big O of n squared solution. Obviously not the most optimal. So how can we figure out a way to sort of improve this a little bit? Well, we got to try and realize what we're actually doing here. For any given element, like we have to test all of them, right? Or at least most of them. So for any given element, what do we really know? The only things that we know at any given point in time is what our target is and whatever current element we're currently at. So given what we need to figure out, what are we missing here off this? Well, we're missing the other number, right? If we have 2 and we know our target's 18, well, we need to find a number of 16 in here then. We need to somehow figure out a quick way to figure out if there's a 16 in this array. So hopefully that sort of sparks your mind there when I say a quick way of finding out of something. We should immediately try and think of a sort of hash map, right? Or maybe a set, but in this case we want to use a hash map because we don't only want to know if we found a 16. If we did find a 16, we want to also know where that 16 was. We want to know the index with it. So that's why we need a hash map. We need that sort of key value pair data structure here. All right, so let's go ahead and assume that we did one pass right at the beginning of our solution here. We're going to go ahead and do one whole pass, iterate through this array one time, and generate this little hash map here. All right, so basically what that would look like is I iterate through every element in here, and I'd say, okay, this element, I have a 2 at index 0, so I'll do a 2 for a 0. Next element, I have a 7 at index 1, so that's a 7 to 1, so on and so forth, until we iterate through this whole array here and generate this whole hash map, okay? So now, once we've done that, now we can go through this array again, and now we can just quickly test, okay? 18 minus 2 is going to equal 16. Do I have a 16 in my hash map? No, I don't. All right, move to the next number. All right, 18 minus 7 equals 11. Do I have an 11 in my hash map? Oh, yes, I do. My 11 is at index 2. So my current index here is 7. My current index of 7 is at index 1. So I'm going to take 1 and this here, which turns out to be 2. So I'm going to return 1 and 2. Same thing that we did before. So now this solution here is going to be O of 2n, which if we know anything about big O notation, we can drop the constants, and that just drops down to big O of n. But can we do it a little bit better even? Perhaps we can do it in just a single pass, to where we don't need to make one whole for loop to just generate this hash map right off the bat. What if we've sort of generated this hash map sort of on the fly? All right, so what I mean by that is I'm going to go ahead and delete all these values here. And instead of, like I said, right away when we first start the solution here, instead of iterating through this whole array one whole time just to generate this hash map, I'm going to do everything in real time here. I'm going to check for the difference and then check our map. If it's not in our map, well, then I'm going to add it to our map. All right, so it might sound a little confusing. Let's just kind of see what that looks like in action here. So first, again, right away, I'm going to say 18 minus 2, that equals 16. Okay, my difference, what I need right now is 16. Do I have 16 in my map? Well, no, I don't. So now I'm going to put this value here in my map. I'm going to say key 2 at index 0. And then I'm going to move on to the next element. All right, 18 minus 7 is going to be 11. Do I have an 11 in my map? Well, no, I don't. So I'm going to put the 7 inside here at index 1. And now I'm going to go to the next element. I'm going to say 11. 18 minus 11, that it's going to equal 7. All right, so do I have a 7 in my map? Why, yes, I do. My 7 has a value of 1. So now I can return index here, which is going to be 2, and 1. All right, and this is now, again, it's also O of n, but now it's a single pass of n. Before we were doing 2n, which I know in the big grand scheme of things, it really just resolves down to n, but clearly this solution is a little bit better because we're not having to iterate through the array one whole time unnecessarily. So let's go ahead and see what this actually looks like in code here. All right, so right off the bat, I'm just going to create a map here, and that's going to be of an integer key with integer value. And I'm just going to go ahead and call this previous, as in the previous numbers that we've seen before. And I'm going to implement this as an actual hash map. Integer. All right. And now I'm just going to iterate through this array here. I'm going to use a conventional for loop. For int I equals 0. I is less than nums. I can't type. Dot length. I plus plus. All right, so now the first thing I want to do is I'm going to get the actual current number right away. So instead of saying like nums at index I every time, I'm just going to put this inside of a temporary variable. I'm going to say current number equals nums at sub I, okay? And now I want to find the actual difference here. I'm going to say int difference equals target minus our current number. All right, now what I want to do is I want to check to see if our previous hash map has this difference number in it. All right, so if previous contains key of difference, if that key is in there, well then I know I can just return. I'm going to get that index. I'm going to say diff index equals the previous dot get the diff, and then I'm just going to return that array of return new int array of our current index I and the diff index that we just got from our hash map. Else, if the difference is not in this map, well, that means then we need to put this current number inside of this map here. So I'm going to say else previous dot put, and that's going to again be current at our index there. And then that's going to loop through the whole array there. I do need a return type at the end of this. And given that our instructions say that we will have exactly one solution, I know that it's going to return at some point in this for loop here. So I really don't care what I return down here, because again, given the instructions, I'm never going to hit this point here. So I'm just going to return a null, okay? But that's it. That's the entire solution there. So let's go ahead and run this code, make sure I didn't make any silly syntax errors, which I can see already I did here, actually. There we go. Let's go ahead and did I make another one? Oh, yep, I did. I made 2 silly syntax errors. That's supposed to be new hash map. There we go. And now go ahead and run that again. There we go. And then I'll go ahead and submit. And we'll see this magic here. There we go, success. 100% faster than 100% of the other solutions because, again, this is the optimal solution here on how to solve this one. All right, so if you liked this video, this little explanation here, this tutorial on how to solve the two-sum problem on LeetCode, please do smash that like button. Please consider subscribing so you can be notified whenever I come up with new videos on either LeetCode tutorials or any other tutorials on my blog over at Pragmatic Ways. I do things such as clean code, refactoring code, design patterns, and data structures, all the good stuff to make you a solid rockstar software engineer. So please do subscribe, and until next time, happy coding, everyone.